correct? If you're not creating tick marks, then most likely you're just cheating, correct? Okay, so here I go. For number 2, how many givens are there? 2. So let's go ahead and write the 2 givens automatically. So we have MP, and wrong pen. So we have segment MP is congruent to MN. And we know that is by the what? Given. If givens are the freebie, please take it. NMO, angle NMO is congruent to angle PMO. And that's by the given also. And then before we notate, can I automatically write our final goal? So that's ON is congruent to OP. The reasoning, we're not sure yet. So we had 10 blanks, and 5 of them are pretty much given to you, correct? Okay, those are at least something you can do, even if you're pretty much lost. So here we go. Start notating. MP, 1 tick mark. MN, 1 tick mark. What should I label next to it? S as in side, very good. And then let's go to angle NMO, this angle right here, and this angle right here. What should I label next to it? Angle. A as an angle. And then looking at this, since we're looking at OP and ON, do I see a shared piece between these 2 triangles? Highlight these 2. And I heard MO, very good. Between these 2 triangles, do we see the reflective property of congruence? Yep. So let's say MO is congruent to MO. We're going to write S as in side. So that's our third statement. MO is congruent to MO. And that is reflexive property of what? Congruency. Very good. I need all of them. Reflexive, the property, and congruency. So now let's see if the triangles are congruent. So I'm going to highlight them in consecutive order. Is this side angle side? Yeah. Side angle side, okay. Naming the triangle doesn't matter how you name it at the beginning, but it does matter on the second one, correct? So Ian, go ahead and name the first triangle. Triangle what?
M N O.
Okay, triangle M N O. So if I went from M N to O, Noah, what's the other one should be consistent with?
M P N.
Good job. And that was by side angle side. And then let's see if y'all remember from 4.6. So we use CPCTC after 2 triangles are what? So have I mentioned that the 2 triangles are congruent on statement number 4? Is ON and OP really corresponding part?
Yes.
So we're going to write CPCTC, which means corresponding parts of congruent triangles are congruent. Okay, if you're good on that, give me a thumbs up. Let's go to number 5. Let's all go to number 5. Okay, on number 5, let's kind of decide on which 2 triangles I'm looking at. So I'm going to highlight something that I don't want you to. It could be these 2 little ones, or it could be these 2 medium size. We're not sure about that. So let's see what's going to give it away. We have, the first one's going to give it away. Do y'all see BX and AW? So if I want to use BX and AW, am I looking at the smaller triangles or the medium-sized triangles? Smaller triangles. Very good. Let's go ahead and start by highlighting them. I have this triangle, and then we're comparing it with this triangle over here. Okay, something is unique on this one. Whoever chose this number 5, good job. Okay? Something is unique. Look at the first 2 givens. Are they exactly the same pretty much? One of them does not have a segment, and one of them does, correct? So let's see if y'all remember. If I go from the exact same BX is equal to AW, and then I translate that to BX is congruent, definition of congruent segments. Let's apply that. So let's start by writing out BX is equal to AW. I did not say congruent yet. That's by the given. And then I want to translate this into a picture. So segment BX is now what? Congruent to segment AW. And as long as it's going from congruent to and equal to, vice versa, it is definition of congruent segments. Can this happen with the angles too? Yeah. It could happen with the angles. If it's with the angles, it'll be definition of congruent angles. Are we good with that? Okay? So now let's go ahead and notate. We have BX is right here. AW is right here. What am I going to write next to that tick mark? S as my side. Very good. My next given, TA, is congruent to TB. And that's also by the what? Given. So TA is right here. TB is right here. And we're also going to write what letter? S as in side. All right. So then let's apply something else on this one. I want to highlight the big triangle as it is. So ignore every other line except the big triangle. So let's see if y'all remember. In one big triangle, if the two sides are congruent, what do I know about the opposite angle? Are congruent. Let's go ahead and notate that. So I know these two angles are congruent to each other. And I'm going to write A as an angle. So let's put on here, we have angle A. It's congruent to angle B. So let's see what was given first. In the big triangle, was the angle given first or the two sides given first? Sides. So here's your reasoning. If two sides in a triangle are congruent, then opposite angles are congruent as well. But you have to emphasize in a triangle, because we can't apply that rule for a rectangle and so on. So now let's see. Let's highlight this consecutively. Is this side angle side again? Do we all see that side angle side? Okay, so let's see how we want to name the triangle. John, how do you want to order the first triangle?
TBX.
This triangle over here.
TAW.
Okay, TAW. Is congruent to, then Nava, how would I order the other one to be consistent? TBS. Very good. Triangle TBS. And that was by side what? Side angle side. And we know our final goal is right here. TW is congruent to TX. And again, we use CPC, TC after two triangles are congruent to. Corresponding parts of congruent triangles are congruent. Okay, if you're good on that, give me a thumbs up. So this was a really good question. Let's go to number 6. Okay, on number 6, let's go ahead and write the first given, and then we'll analyze which two triangles we're looking at. So we have OM bisects angle PMN. PMN. What's the reasoning for this one? Given. So I'm saying that MO or OM is cutting PMN in half. Let's go ahead and notate these two angles are congruent too. So let's label A as an angle. So let's see how I know which two triangles. Don't highlight yet. It's either this triangle and this triangle down here, since I have to use that angle, or it's this triangle and this triangle over here. What do you guys think? Small one or the big one? Big one, because our proof is including the big one. Do we see that? Okay? So let's go on to our next thing. We notated the two angles we're congruent to, so we want to go ahead and specify that. Angle, I think I want to go ahead and say NMO is congruent to angle PMO. And y'all remember, the diagonals must have the same word, right? So it'll be definition of what? Angle what? Bisector. So again, bisector. Look at the diagonals, they match, correct? Okay, let's go on to our second given. Okay, Anna, what's the second given?
Segment NP is congruent to segment MN.
Very good. MP is congruent to MN. My M is struggling. And that's by the what? Given. Let's notate it. So MP is right here, S. MN is right here, S. Do I have a shared side again? Who is it? MO. MO is congruent to MO. And that was what property? Good. Reflexive property of congruency. And let's label them right here. And let's call it side. Is it side angle side again? I guess side angle side wins today. At least for these three problems. Okay, let's see how we want to order them. Max, how do you want to order the top triangle? Triangle what?
M and O.
Okay, M and O. Then Sydney, how would I be consistent on the next one? Very good. MPO. I forgot triangle. And that was by side what?
Angles.
Angle side. And we know our final goal is always the proof. ON is congruent to OP. And again, as long as we have two triangles are congruent, the next statement is CPCTC.